Welcome to Unfold Data Science, friends. My name is Aman and I am a data scientist. In next 10 minutes, I am going to explain you k-means clustering in a very simple and easy way. I am going to tell you stepwise process of what happens in k-means clustering and also going to show you in Python how to implement a simple k-means clustering. Okay? If you watch this video till end, this topic you will not forget easily, that I can assure you. Okay, let's start, guys. What is k-means? K-means is nothing but a technique to cluster. What is clustering? I had created a detailed video, the link is here, you can watch this. Clustering is nothing but grouping similar things together. Those similar things can be customers, products, websites, anything which has certain features and attributes, right? Now, when we want to group similar things, then we will consider its attributes, right? So what I'm going to do here is I'm going to create a simple XY chart first. Okay, I'll come to this side of the board later. Simple XY chart. In this chart I'm going to put income and expense of people. Okay, for example, here I am putting expense and here I am putting income. Okay, now there might be people who might be earning less but spending little higher. Okay, let us assume there are some people like this, so their income is lower, let's say in this range, and their expense is little higher side. Some people, not everyone, but some people. On the other hand, there are people whose income is more, which means they will be somewhere this side, and their expenses similar to these guys. So I can say something like this, not too different from these guys. What I am coming here to say is these guys are aggressive spenders. Even if they earn less, they spend more. These guys, even when they earn more, they are spending similar to these guys only. So there is a behavioral difference, and that is what we intend to do in clustering. We want to understand the behavior of different customers. In this case, let's say customers. Now what we will do is we will understand when we take this and submit it to k-means in Python or R or any tool, then what happens. Okay, first of all, how many clusters you want, that is k, the value of k. The first step in k-means clustering is knowing how many clusters you want. How to know this k, I will discuss towards end of this. First of all, let us assume for now let us assume k in this case is 2. Since there are two groups of people who kind of behave similarly, one is this group, one is this group. One is not very aggressive spenders, one is aggressive spenders. Let us say in our case k is 2. This is the step number 1. What happens next is initialize the cluster centroid. What is cluster centroid, guys? So when I say this is my one cluster, which means there are many people in this cluster, right? So there will be a central point of this cluster. You can say this as a central point of this cluster. That is nothing but centroid. Okay, so what will happen as a next stage is the Python will initialize two random centroids. Okay, random centroids from the data itself. If you say one argument is there, if you say random, then it will take random data points from these and think this is the cluster centroid. Let us assume for simplicity this data point is randomly initialized centroid for cluster 1 and this data point is randomly initialized centroid for cluster 2. Clear up to here? This is step number 2 done. Now what will happen is all the data points will be seen for the assignment. Okay, now we have how many data points? 1 2 3 4 5 6 7 including the centroid. 1 2 3 10 data points. All these data points will be assigned to one of these centroids. Which centroid? Whichever is near. What is near in this case? I had created a detailed video on different distance matrices. The link is here, you can watch. In this case you can consider the Euclidean distance. When I say near or far, Euclidean distance you can consider. Okay, so this point is closer to this centroid. So this point, for example, is it closer to this centroid or this centroid? Obviously this centroid, so assign to this. Fine. This point, is it closer to this centroid or this centroid? This one, so assign to this cluster. This point closer to this one or this one? This one. This point we do not know, it can be closer to this also or this also, we do not know. Whichever is closer in Euclidean distance, it will be assigned. One assignment is complete. What happens next is, after assigned clusters, the new centroids will be computed. This is very important to understand, guys. What is new centroid here? Imagine, understand, the first centroids were randomly initialized, but the next centroids will not be randomly initialized. It will be a mean of all the data points in this cluster. For example, if I say that these 3 points are in cluster 1, just for example I am saying, and these 3 points are in cluster 2, then the mean of all the x values and mean of all the y values, that becomes the new cluster centroid. The mean of all the x values, mean of all the y values, that becomes new cluster centroid for cluster 2. Now we started from this centroid, but in the iteration 2 we got a new centroid. Let us say that new centroid is somewhere here, or this point is this centroid. Now what happens, guys? Again assign cluster. How? Again see the distances of all these points from both the centroid. Whichever is near, assign to that. So there will be some shift. There will be some points which will move from one cluster to other cluster. Okay? And then centroid will change again. How? Take the mean of all the points in one particular cluster. That becomes the new centroid, and iteration 3 starts. Every time centroid is shifting, one iteration is getting completed. Okay? Iteration 1, iteration 2, centroid shift, iteration 3. There will be a point where it will be no shift in the centroid, which means new centroid and old centroid will be same. And that is where your clustering algorithm converges, or it says that these are the final clusters. In k-means clustering, when you call in Python, you can give a parameter called number of iteration is equal to, let's say, 300. Then the centroid shift will not happen more than 300 times. Okay, that is a parameter you can pass, but it will automatically converge before that only if you have a simpler kind of data. Okay, so this is how choosing k, initializing centroid, assigning the data points to those centroid, calculating mean for the new centroid, and reassigning the data points. See here, reassignment, move centroid, reassignment, move centroid, reassignment, move centroid, and finally converge. Converge means if the centroid is not changing, that is nothing but convergence. Okay. Now one important question, guys, how to choose this k? Okay, this is also an interview question. I will discuss about this in detail in my next video, but for now I am going to give you some idea. I am going to give you. So guys, whenever clusters are created, right, whenever clusters are created, there are two intentions behind it. Intention number 1 is the points in a cluster should be closer to each other. Okay, for example, if this is xy, this is for example one cluster, and this is for example other cluster, right? There are two things that we are trying to achieve. Points in the cluster should be closer, and distance between the clusters should be far, which means two clusters should not be close to each other, and points within the cluster should be near to each other. Okay, how do we measure that points within the cluster are near to each other? How do we measure that? What we do is we just take the distance of all these from their centroid. When I say distance, again Euclidean distance you can think of. Okay, now let us say there are 5 data points. Take all the, for example, there are 1 2 3 4 data points. This is centroid. All these 4 points, what is the distance from the centroid? Euclidean distance. That becomes the distance. Sum it up, that becomes the distance of cluster 1. Same thing for cluster 2. When you sum it up for all the clusters, right, that number is called inertia, or within cluster sum of squares. Our objective was to minimize that. minimize that. I told within cluster distance should be minimum, right? Now to choose k, one method that is very popular and everybody talks is known as elbow method. What we do is, since we don't know what is our optimal k, whether it is 2, 3, 4, 5, 6, we don't know. What we do is we roughly take a range of, let's say, 1 to 10, okay, and we see what is this inertia. For example, when I have 2 clusters, then what is the inertia of all my clusters? When I have 3 clusters, what is the inertia? When I have 4 clusters, what is the inertia? So what you will see is, I am just going to plot this here quickly. What you will see is a XY chart like this. On one axis you will have inertia, okay, inertia, and here you will have value of k. So 2 clusters, 3 clusters, 4 clusters, 5 clusters. What is my value of inertia at all these clusters? So for example, 2 is here, 3 might be here, 4 might be here, 5 might be here. So at the moment you see a steep decrease. This point becomes your optimal number of clusters. Why? Because we do not want to have many clusters also. There are things around this which I will discuss in the next video, guys. There are interview questions around this, okay? Before that, let me show you how to do the same thing in Python. Let's see in my screen. Hey guys, so here one simple example, right? I'm importing some of the packages here, and if you can see, I'm importing from sklearn.cluster import kmeans, okay? Now kmeans we will be implementing. I have a simple data here, df, I'm reading that, and let me show you head of df so that it becomes easier for you, and then I'm obviously plotting df below. So df.head, same kind of data that I was explaining you, just 2 columns, income and spending, okay? And I have created a data to demonstrate you in such a way that there are people, I have plotted the same data, okay? There are people who are earning less but spending little higher. There are people who are earning little more but spending in the similar range. So savers and aggressive spenders, you can say. Now the first thing is choose k, right? So as I was telling you, there is an elbow method for that. What I'm doing here is, I don't know what is my optimal k. So I'm running 5 k-means model here. If you can see, I'm saying for I in range 1 to 5, k-means is equal to number of clusters is I, which is in for loop. And then I'm passing my data df, right? I'm appending all this score and I'm getting a elbow curve like this. Now, if you see this elbow, guys, this is nothing but clustering score, or what I was telling you is inertia. If you see here, I am taking inertia. K means dot inertia. Inertia is nothing but within cluster sum of squares, okay? It will reduce with increase in K, okay? But I told you whenever there is a steep decline, that becomes our optimal K. So in this case, 2 is our optimal K. So how inertia is changing, if you want to see, you can just see here individual clustering score I have put in this list, right? So previously it was 12K, now it became 559 suddenly. So a huge shift, right? That is why I'm taking as 2. Now I'm considering that 2. I'm saying k-means model is equal to number of clusters is 2, fit on df and predict also what is my cluster number. So as you can see, it is predicting first 10 observations in cluster 1 and next 10 observations in cluster 0, 2 different clusters. I will take this data and I will paste this as a column in the df itself. Now df looks like this, and I'm plotting the df again with different colors for different clusters. So as you can see, aggressive spenders are in blue and savers are in orange here. Okay, so this is how our 2 clusters are looking like. If you want to see where the cluster centers are, then you can just say k-means dot cluster centers, and it will give you, guys, see here carefully, it is saying the first cluster center is 31.6 on x-axis. Where is 31.6? Somewhere here. Where is 22.12? Somewhere here. So here where I'm hovering now, it says the cluster centroid for first cluster. Makes sense, right? It should be somewhere in the middle. So somewhere here it says, which is okay, right? Makes sense. Second cluster should be somewhere here. Let's see what are the points. It says 82 and 24 roughly. So where is 82? 82 is somewhere here and 24 is somewhere here. So somewhere here, right? So makes sense. So this is our final clusters. Many parameters you can pass here, guys, in k-means when I'm calling this. For example, how many iterations you want, how many times you want to initialize. For example, this is one initialization. I want to initialize one more time with random clusters, right? So as I told you guys, there are many interview questions. I have just put the heading here. In my next video, I will take, 8, 10 of those important interview questions and I'll tell you how to answer that in interview. Okay. So that you will create a very good impression before the recruiter. In this video, if you have any doubts, guys, obviously write me in comment. I'll see you all in the next video, guys. Till then, wherever you are, stay safe and take care.